Okay, on to example 2 of solving linear equations. And I'm really going to go through in detail all of my thinking as I go through this. So I could solve this in 20 seconds, but that's not really the point of this. I want to make it very clear what is going on here because understanding is important and that's what this is really about. So the question says solve this equation here. Now, I'm thinking a few different things here. First of all, you can see you've got x's on the left-hand side. Again, the left-hand side meaning everything to the left of the equal sign, and I've got x's on the right hand side, which is everything to the right of the equal sign. And that's not useful, right? They've got to be onto one side and the numbers on the other side. So that's something to bear in mind. But I've also got brackets, and whenever you have single brackets, just expand them, distribute everything out. And let's go and do that. So with the first bracket on the left hand side, we've got half and we're timesing it by x, and then half and we're multiplying this by the 8. Now, half times by x you can write in different ways. You could write it as half x, like this. That's fine. That means a half times x. Or you could write it as x over 2. Okay, also means the same thing. How would I write it? I'd probably write it as half x personally, but it doesn't really matter too much. Okay, half x like this. As long as the x is not on the bottom, this is something different, right? Do not write this. That's wrong. Okay, so a half x is what I've got here. Now, a half times by 8, or what's half of 8? It's 4, so plus 4. And we bring down the equal sign, and then we can, well, this 2x over here, this is a term on its own. So just leave it on its own for the time being. So you've got equals to 2x. You can then go and distribute out the third to the 4x and the third to the negative 5. Maybe you're thinking, oh, what's going to happen here? It's just timesing fractions, okay? So you've got a third times by 4, which is really just if you've got 1 over 3 and you're timesing it by 4, and before you can write it as 4 over 1 because that is what 4 is as a fraction. And timesing fractions is really easy. 1 times 4 is 4, 3 times 1 is 3, so 4 thirds. So a third times by 4, x is going to be 4 thirds x. So plus 4 over 3 x. Again, you could write it as 4x over 3. I would write it as 4 thirds x. And similar sort of thing, you've got a third times by negative 5. Well, just think about what's a third times by 5, which again you can write as 5 over 1, because what is 5 over 1? 5. And then timesing it, 1 times 5 gives you 5. 3 times 1 gives you 3, so 5 over 3. So these are skills that, I remember when I first started doing my AS Maths, my skills on this were just a bit poor. I was making little mistakes all the time, so I just drilled in these kind of questions, right? So now it just becomes, bam, I don't even think about it. But that is the stage that you guys will get to. If you're already there, perfect, okay? So we've got a third times by negative 5, which is minus 5 over 3. Now this is looking better, but you might be thinking you've got fractions here, the x's are still on different sides. Deal with one thing at a time. Now, because I can see here I've got fractions which are never really that useful, okay, when you're trying to solve something, let's begin to deal with this. Now I can see here I've got a couple of dividing by 3's. Now to get rid of those dividing by 3's, to cancel them out, what's the opposite, the inverse of dividing by 3? Multiplying by 3. So we said on the intro video, you can do whatever you want to an equation, but you must do it to every single term. So if I times this by 3 and this by 3, so the 3's cancel out, I've got to times this by 3, this by 3, this by 3, every single term by 3. I'm really stressing this, it's really important, okay? Often people just apply it to one thing. You've got to do it to everything. Otherwise, your equation becomes unbalanced. You might have seen lower down your school years that if you do something to one side and not the other, your scales, they're not balanced. You've got to keep them balanced. Now, if we work through this, okay, well, what is a half x timesing by 3, or the same sort of idea as over here? I'm going to go back to red pen. 1 over 2 times by 3, or 3 over 1, is just simply going to be 3 over 2, okay? So really important that your fractional work is really solid, otherwise everything becomes a nightmare. So half x times by 3 will give you 3 over 2x, done. I then do 4 timesing it by 3, which is plus 12, good. I bring down the equal sign. I'm keeping every single thing lined up. I kept this lined up, the equals is lined up. It just makes things really organized. I've then got 2x timesing it by 3, which of course gives you 6x. I've then got 4/3 x times by 3. And this is the whole point here because, well, if you had something being divided by 3 and you times it by 3, it just goes to 1. Yeah, they cancel out effectively. So this 3 will cancel with this 3, and you can see you're left over with just a 4x on the top. So you've got the plus 4x up here. And similarly over here, you've got minus 5/3 timesing it by 3. Well, dividing by 3 and timesing by 3, they cancel out, they give you 1. Okay, so that's why they're going to disappear, and you're left over with a negative 5. So you've got minus 5 over here. Good. Okay, excellent. Now, in the middle part down here, we can do some simplifying. Okay, we've got a 6x and we've got a plus 4x. Well, that's going to go to 10x, so let's just go and write that out. Actually, before I do that, I'm going to be a bit sneaky. I'm going to write this in one go as 10x. Okay, so I kind of combine it there, just to save a step. Now I can still see here I've got 3/2x over here. I've got this dividing by 2, and you don't want fractions. Let's get rid of that. And now think, what's the opposite of dividing by 2? To multiply by 2. But I've got to multiply every single term by 2, times everything by 2. Because then, of course, the dividing by 2 and the timesing by 2, they cancel. They're opposite operations. Okay, a bit like 3/3 is 1. Of course, 2/2 gives you 1. They just go to 1. So that's going to go. I'm left over with 3x times the 12 by 2 gives you 24. And that's equal to 10x times by 2 is 20x. And I've got, of course, negative 5 times by 2 is negative 10. Good. Now, from here, we're getting closer. You want to get the x's onto one side and your numbers onto the other side. Now, I could put the 20x onto my left-hand side. If I do 3x, take away 20x, it's going to go negative, and it's just going to add on an extra step and maybe create confusion. So the best thing to do here is to get the 3x onto the right-hand side by doing the opposite of a positive 3x, which is to take it away. So look, if I was going through this myself, I wouldn't write this all out, but it's useful to think about what is going on. So what is happening now is I'm going to go and take away, so a different color, take away 3x over here, because of course 3x minus 3x goes to 0. And I can also go and take away 3x over here. You must do the same thing to both sides, the left-hand side and the right-hand side of the equation, to keep it balanced. It's really important. Okay, so now left over, I've got 24 on the left-hand side is equal to 20x take away 3x will give you 17x, and the minus 10 is still left over. I'm now really close. I want to get the x on its own and the numbers on the other side. Well, this minus 10, I can bring it over here by doing the opposite of taking away 10, which is to add 10. So let's go and do that. Again, look, when you get really good at this, you're not going to bother writing out add 10 to both sides. You can do this really quickly, but I'm just showing you what's going on here. So we can add 10 over here. We can add 10 over here. They're going to cancel out, so they go to 0. I'm going to bring the equation up here. So we've got on the left-hand side, 24 plus 10 gives you 34, being equal to, left over on the right-hand side, you've got 17x. Okay. Now 17 times by what gives you 34? 2. In other words, what's 34 divided by 17? 2. So x is going to be equal to 2. And this here is your solution. And again, like on the previous video, you could check your answer by putting it back into the equation up here. Okay, and it should be the case that the left-hand side equals the right-hand side. You can do that if you want to. I'm not going to because of time reasons, really, and I don't want to bore you to death. But that's it. So look, I spent almost 10 minutes going through this. We could have gone through it in 1 minute, okay? And if I was doing it myself, and when you guys get good at this, you'll do it in 30 seconds. But it's really important you understand what is going on here. You're not just kind of doing something and it all goes wrong early on. You have like a structure, which is what I was saying on the intro to this video. Like here you can see you've got x's on both sides, get them onto one side, deal with any brackets, collect up any like terms, deal with any fractions. And that's it really. Look, this is it for solving linear equations. The thing is, I could go through loads of examples on this, but again, like I said on the intro, it's recap really from GCSE. And the best thing you can do is now go through exercise 1C, do the questions as best you can. If you need help, come and see me, or comment in the questions below, and I will make a video going through that particular one, because there's hundreds of examples I could go through, and it's just one kind of recap part of the course, and there's loads of new content that we need to really be getting through. So that's it for this video. Thank you.